All right, this is going to be the walkthrough for the homework assignment titled More Linearization and Differentials. So we're starting off with the approximation for the square root of 25.02, which means we're going to use f of x equal to root x, where f prime of x is equal to 1 over 2 root x. Okay. The x value that we're interested in is 25.02, and our center of approximation, A, is going to be 25 because that's the closest number to 25.02 that we know how to square root. So again, the formula for linearization is just linearization should give you f of, the linear approximation should be f of a plus f prime of a times x minus a, just like from the last homework assignment. So we'll start off with root 25 plus 1 over 2 root 25 times 25.02 minus 25, which just gives us 5 plus 0.02 over 2 times root 25, or 0.02 over 10. And so that's the same as 5 plus 0.02 over 10 is 1 over 500. Right? You can turn 0.02 into 1 by multiplying by 50, and 10 times 50 is 500. So we have 5 plus 1 over 500, which would be 2501 over 500. For our next one here, we want the cube root of 63.97. So we're going to use the cube root function, right? F of x is going to be cube root of x, which is the same as x to the 1/3. And f prime of x will be 1/3 x to the negative 2/3, which is the same as 1 over 3 x to the 2/3. Our x value is 63.97, and our a value is the closest thing to that we easily easily cube root, which is 64, right? Because 4 cubed is 64. So the cube root of 63.97 should be approximately equal to f of a, so the cube root of 64, plus 1 over 3 times 64 to the 2/3 times 63.97 minus 64. And then, of course, we'll just simplify all this down. This is 4. In the numerator, we have a negative 0.03. So we'll just say 4 minus 0.03 over 3 times 64 to the 2/3. Well, the cube root of 64 is 4. And when you square that, that would be 16. So this is 3 times 16. We can cancel out the 0.03 with the 3, just making that 4 minus 0.01 over 16. Now, 0.01 over 16 is the same if we could make that 1 over 1,600 if we just move the decimal over, right? So 4 minus 1 over 1,600. Well, 4 is 6,400 over 1,600. So this will just be 6,399 over 1,600. For our next one, we are looking at a spherical ball that's being heated so that its radius increases by 0.011. We want to estimate the change in the volume of that sphere when it goes from 5 millimeters to 5.01 millimeters. So this is a differentials question using the volume formula for a sphere. Volume is 4/3 pi r cubed. So dV should be 4 pi r squared dr. In other words, the change in the volume, the very small change in the volume, dV, is equal to the derivative of the volume equation, right? Its instantaneous rate of change times the change in the radius. So r is going to be 5, where dr is going to be 0.01. And then we'll just plug it in. We get 4 pi times 5 squared times 0.01. Well, 4 times 25 is 100, times 100 is just 1. So we're just left with pi millimeters cubed. And for our last one here, we want to use a differential to find the sine of 46 degrees. So our function is going to be sine of x, and the derivative is going to be the cosine of x. And the x value we want is 46 degrees, and the a value would then be 45 degrees, because we can evaluate the sine of 45 degrees really easily. So we should end up with f of a, so sine of 45 degrees, plus the cosine of 45 degrees times x minus a, which is 46 degrees minus 45 degrees. But the problem there is going to be that in the real world, degrees don't really mean anything, right? Radians have a real measure in the real world, so we must convert the degrees here into radians. So we have to multiply by that factor of pi over 180. And so what we end up with is root 2 over 2 plus root 2 over 2 times pi over 180. Right? And we don't have to convert these because we're using a trig function to evaluate. Right? If I say the sine of pi over 4 or the sine of 45 degrees, that's the exact same thing. And so this just ends up being root 2 over 2 plus pi root 2 over 360. And that was it, just a short assignment. That's the end of the more linearization and differentials homework assignment.